where there were situations where you might have to use substitution, like the one just above it, different situations to watch when you check your answer. What I want you to think at this point is anytime you see an equation with a denominator, you want to times through and clear that fraction. So, fractions all around. And this actually would represent the LCD because this last fraction, its denominator, factors into exactly these two values, these two factors. So this is the LCD. He times it onto each side, x minus 5, x minus 8. Remembering that multiplication is distributive, so if you multiply on each side, it will distribute through each side and clear all those fractions. So first fraction, when we distribute, x minus 5s are diagonal, so it just leaves a 3 and x minus 8. No denominator, right? We're wiping those out with the LCD. Then use this again, distribute it to the next term. The x minus 8s are diagonal, therefore cancels that out and just leaves an x minus 5 becomes positive 7. And then lastly, this is just great. The whole thing matches, and it is diagonal multiplication, so it all cancels out, and you're just left with a 5. Now we have a much better equation to deal with, to tackle. You can distribute. And a big thought here is you notice when you were retaking your quizzes today, is after you distribute and do whatever you're doing to get your problem going, then you discover if it's linear or quadratic. This is linear because x is to the first, so I would gather my x terms, and the constants go to the other side on linears. Right? On quadratic, you wanted it all on one side equal to 0, but if it's just x to the first, all the constants go to the other side. So minus 24 and minus 35 become plus 24 and plus 35. So combining all that together is 64. And then divide by what's with your variable. Divide out by 10. And x is 64 tenths. We should reduce that to 32 over 5. One issue with the fraction ones is if the denominator has a variable, you always have to say, is my answer okay? Because there's been instances where we get an answer we'd throw out. Like if the answer would have been x equals 5 or x equals 8, we would have had to have omitted those answers. We couldn't have put it back in the original problem. Okay, so just remember when you're solving an equation, you're finding what would work back in the problem. And we should probably always pursue checking. We don't always do that, but it's a good idea, especially on the test. Okay, number 25, a reading application of work. You need to know that work, kind of like distance, is equal to rate times time. And if you think about it, that kind of makes sense. How much work you get done is affected by how fast you're working and how long you work. I mean, that kind of makes sense. And those are the two factors affecting work. Well, so in this problem 25, and in all problems, you want work plus work to equal one job completed. You want to know how long will it take them working together. So it's two parts working together. If they're working together, it is plus. If they're working against each other, like if you were cleaning the house and you had a toddler who was messing up the house, you may never get that, right? You know, you've got something working against you. So if they're working against one another, we do put a minus sign here, and that's what's happening in this number 25. A normal maybe work problem is two people working on a job, two painters working together, two people mowing a lawn together, raking the leaves, whatever. They're together working at a steady speed, and then it asks how long to get the job done together. So normally we say plus like that. But again, if they're working against each other, like this problem, we say minus. And the reason it's against is you've got one inlet pipe, you're trying to fill up the tank with an inlet pipe, but then you've got an outlet pipe that was left open, so it's draining the tank, so against each other. So the rate of work of the first pipe, the inlet pipe, it says it can fill the tank in 5 minutes. So that's 1/5 of a job per hour. That's its rate. The rate we always convert over to 1 over the time it takes it to do something. Like if it takes me 3 hours to mow my grass, my rate is 1/3 per hour. Okay, if it takes you 5 hours to do something, your rate is 1/5 per unit of time. So it's always 1 over how long it takes you to do it. That makes your rate. So 1/5 of a job per minute for this pipe times time, which is our big unknown in this problem. The other pipe, the outlet pipe, it says it takes it 7 minutes to drain. So it's a little slower, so that's why we will eventually get this pool or tank filled up. But its rate is 1/7 of a job per minute times unknown time. So rate times time, that work, minus rate times time, that work. We want to know when will it get the job done, equal 1 job completed. All right, so we times through by 35 to clear the fraction. That's our LCD. 35 times 1/5 makes 7 times T, that's 1 term. Then distribute. 35 times 1/7 is 5T. And don't forget, 1 times 35, we have to keep the balance of the other side. So that is 2T equals 35. Divide out the 2. 35 over 2. 17.5 minutes, but the tank will eventually fill up, right? Just slowed it down a lot. Okay, 26. Some of y'all were just doing this question, I noticed on your retake of your quizzes. On yours, they had the 5 thrown across first. They already had the radical isolated. So if not, make sure you do that. Before you can square both sides, you have to get the radical alone. So the 5 thrown across, x minus 5. Then you can square each side. The square and the square root cancel out. Don't forget to square the other side. This foils. Remember, squaring does not distribute. You know what I think? Sometimes because I've been doing this LCD stuff and I put my multiplier kind of up in the sky on each side of it, it looks the same as this thing I'm doing here, but it's not the same. Timesing through by LCD is multiplication. This was squaring each side. So it looks kind of the same visually, but I'm saying something totally different. I'm squaring this. To square a binomial will not distribute. It means x minus 5 times x minus 5, which can be FOILed out to get x squared minus 10x plus 25. When you see it as a quadratic, that clues you in that you need to get it equal to 0. You can go either direction, but it looks easier if I'll get this side 0, 0. So I take the x across minus x and the 7 across minus 7, and it looks like that. So now this is a quadratic equation in standard form. It will factor. Then set each part equal to 0, and that gives you your 2 solutions. Well, this happened to you on your quiz. I know for the particular one that we were looking at earlier, one of those does not work. So you have to always check these. Sometimes they both do, sometimes neither, but there's no pattern. You just have to check. So make sure you do that on your test. If you have a radical type problem, the answers have to be verified. So we plug it back into the original. 9 plus 7 plus 5, does that equal x, which we're plugging in as 9? The square root of 16 plus 5, that is a true statement. So that answer is verified. Now check with 2. 2 back in for the original x. 2 plus 7 plus 5. Does that equal x is 2? Square root of 9 plus 5 does not equal 2. You see how that just doesn't work. So we cannot use that as a solution, even though on the answer key, you may have a choice that says 9 and 2. You'll totally miss it if you do that. You have to make sure you finish the little details and check it.